Yeah, it's just apparently they're waiting on someone else at Monash to come.
Yeah.
But
He's just arrived.
Oh, sorry. Anyway. Oh, yes, it's fine. Okay. So in case you haven't noticed, I have a cough. I hope I'll be fine for the training. But if I'm getting too hard to understand, don't hesitate to tell, because someone else from CMS can take over. So, so that's the last session for this basic Python training, and we're finally going to see arrays and netcdf files. I told you the training material was in a GitHub repository. If you have it on your computer and you have it here, if you open Jupyter Notebook, you should see something like that. And that's the notebook we use today. Okay. 2 weeks ago, we saw a few packages with Python that we think are useful. One of them was NumPy, and NumPy is the kind of generic array package for Python. So if you want to use arrays, you will need to know about NumPy. So you do import NumPy, and often it is aliased as np. So if you see in questions something like np.something, that's usually a NumPy function. Okay, the first thing to know is how to create an array. Obviously, you can read data from file, but you might need to create an array from scratch. There's a low-level function, which is ndArray. And I want just to show you, before we were using the basic Python, so the functions were not just the name of the function. In this case, because it's a function from a package, you have to do np.ndArray. You know, that's from this np package. This is kind of low level, so you may not use it that often, but on the web page for the function, you have a list of all the attributes and methods associated with NumPy arrays, which are called ndArrays. So it can be useful for you to check this web page and have a look through. It doesn't mean that all the functions are developed by NumPy. You have also different functions, but it gives you a first idea of what's there. So if you use this low-level function, you define your array by giving the shape, and then you also give something that's called data type. So whether you want float, integers, strings, whatever you want. I mean, not really whatever you want, but you know, you can find the information on the NumPy doc of what data types are available. And so if I do this, oh, sorry, I forgot to import the NumPy thing. So if I do this, you see I have an array. It is not initialized at 0 or anything, you know, it's like random weird numbers. So be careful if you do that, because you don't have zeros. But yeah, it's how the output of a 2 by 4 by 3 array would look like in Python. Okay. Obviously, you can use the types like list or tuples to create arrays. So here you see it's a list, and each element of the list is another list that has 2 elements. And in this case, I get a 2 by 2 array. Each of them become, okay. And you can see it's not a list because there's not a comma between the, if you're wondering. As I said, you can have a lot of data types, and so NumPy doesn't necessarily mean doesn't necessarily mean you need to have numbers. It can accept strings as a data type. So this works. That's absolutely an array, so be careful when you have your own arrays to know what type you're using. And it can also be a mix of different types. So here you see I have strings and numbers, and it's absolutely acceptable. Obviously, you want to be careful at the start, not necessarily mix data types because it's harder to process, can be harder to process. So just be careful with that. I'm just mentioning it because when you read data from file, if you have a string and numbers, you might end up with an array like that that has different data types in it. Okay, so, oh yeah, and I forgot to say, when you want to convert from list or tuple, you don't use np.ndarray, but np.array. So if you remember, there was the list and tuple function before to transform something into a list or a tuple. So here, to transform something into an array, use an array function, except it's come from NumPy. Okay, so this can be quite often used, the array one. You define your data in a list and just transform it in an array. You may also want to give a shape of an array and initialize to 0 or 1. So there's np.zeros and np.ones. And here, the tuple is not the values, but the shape of the array. And then you can choose whatever type you want for those. So you see that my array of zeros, they have a dot, so that's float, and my array of 1 don't have a dot, so that's integers. Yeah. The other thing is you can use the shape of an existing array to create a new array full of zeros or ones. So you have zeros like or ones like functions, which typically takes the shape of this array and just create another array but full of zeros. So R1 was full of ones, and R2 is the same shape but full of zero and the same type. Okay. After, if you want, let's say you have a grid and you want to recreate your coordinates of your grid, and it's like a half-a-degree grid from -90 to 90, and so you want -90, -89.5, -89 or whatever. You can do an evenly spaced value. If you remember, there was a range function in Python to do from a certain number to a certain number every x step. So for arrays is arange, for array range. That's the start of the values, that's the end not included, and that's the step. So if I run this, you see we have 5, 7 there, up to 43, but not 45. Okay. So, and here I used full values, but you could put here something like 0 to 10, 0.5, and you get decimal values. It doesn't. The step doesn't have to be an integer. And finally, you can reshape an existing array. So arange gives me a 1D array. I will rerun it as initial because I can reshape it at the condition that I keep the same number of elements. So 5 times 2 times 2, that's how many I had. So it gives me a 3D array with the same values, just reshaped. Okay, so that's all about the creation of arrays. Any questions so far? No. Okay, with data from file, you probably not remember completely, but there was a an example in the last training to read a kind of a tabular data. And typically with normal Python, you had to read everything as a string and then do some processing to transform, to separate the string into different columns and then numbers and things like that. So NumPy has a function that's called load.txt that does all this for you. You just need to give the name of the file as a delimiter, if it's a comma or anything else. It can keep rows at the top for headers. It can keep rows at the bottom for footers. So you can just read the tabular data. And the nice thing about having it in an array is that it will read it rows by rows, but if you want it columns by columns, then you just take the transpose and then you get it. And it also allows you to directly have each column in a different array. So if I run all this, that's the first output you see. It's 2 lines of 3 data. Column 1, and if I do the transpose, I directly have the data ordered by columns instead of rows. And the last one is I have each data in a separate array. So that's much easier to use to read tabular data than straight on Python. So in general, I would say if you have a file that is in a format that is somewhat commonly used, there will be a function somewhere that will read it relatively easily. You don't need to rewrite all the way of reading it. Obviously, if it's your own personal format, it will not happen. But yeah. Okay. So let's go and see at indexing. So we already saw the indexing for lists and tuples. Here for arrays, it's identical, except that there is a several dimensions. So to select along different dimensions, you do a comma between the numbers. So the R2, if I remind you, was here. It has a 3 dimensions. It has 5, 2, 2. I should have put a 0 there. It works better. Anyway, this will give you the first element of your array. And this will give you, the first element in the second dimension and all the other elements. This will give you the first 2 elements in the first dimension and everything else in the other dimensions. And you can obviously, again, use a stride on one of the dimensions. So again, it's all the same syntax as for lists and tuples. So that's what it looks like if you look at the output. There's one thing that is very handy sometimes. So this one, for example, was the first 2 indexes along the first dimension and everything else on the other dimensions. In NumPy, you have a generic form to say this, so that you can code in a way that you don't need to say how many dimensions you have. So it will work for a 2D array or 3D array or 4D array. So this, I say I want the 2 first elements on my leftmost dimension and then everything else is actually the same thing as this. And so everything else is 3 dots, like, everything else. So in this case, it will work whatever the shape of my R2 array is, whereas this one will work only if I have 3 dimensions, at least. Obviously, I can choose more than 1 dimension and then put everything else after. And I can also say everything else before and work from the last dimension. Obviously, you can't have everything else, middle and everything else, because then NumPy doesn't know where the middle is to be taken. But you can do either everything else from the left or everything else from the right. Okay. And you can see that the first form where I specify every dimension is the same as the second form here. It's just exactly the same. And yeah, it works. Yeah, it works in all the cases. Okay. So I don't know if any of you here are coming from MATLAB, but there's a big difference between MATLAB and NumPy or arrays in Python. For MATLAB, the premises is that you use matrices, and in Python you use arrays. So it means in MATLAB, when you multiply two arrays, you get the matrix multiplication. In Python, that's element by element multiplication, so it's quite different. NumPy has a very extensive information page on NumPy for MATLAB users, and there's quite a lot of information at the top. What's really useful, I think, is equivalence of how you write something in MATLAB and how you write it in NumPy or Python, so that you can transfer from one to the other pretty quickly. Okay, so how do you do an operation on your array? Well, some of the arrays have some method for the most common operations. For example, to do a min on your array, you simply do the name of your array dot min. That will give you the total min over your whole array. You also have other functions that are developed by NumPy that will be np dot the name of your function and then the name of your array and so on. So you would have to look through the NumPy documentation to find them all. Yeah. Okay. What is also interesting is that obviously, usually you don't want the mean over the whole array. You might want the mean over, I don't know, time or longitude, something like that. So to do that, you use this notation. So you still use the main function, and in it you say axis equal the index of your axis. So if you say your time is your first dimension, you put axis equals 0 because indexes start at 0 in Python. And if you want to do the mean over the last dimension, you do whatever is the last dimension, and so on. So in this case, if I remind you, R2 was a 3D array. You get a 2D array with the mean along the first dimension in each of these. Okay. Any questions so far, or?
Yeah, no.
Claire, can you hear me?
Yeah.
Yeah. What's the syntax if you want to do a mean over the first dimension and the second dimension?
Sorry, I forgot. I forgot because I usually don't use NumPy, but you can do it one at a time. So you can do axis 0 and axis 0. Scott, can you do it all at once?
Try using a tuple for your axis.
Oh, tuple, yeah. Let's see. Yeah, so you do a tuple of your dimensions.
Yeah. Thanks.
Okay. Okay, working with time, because in the field we all have arrays that have time dimension most of the time. And time can be tricky because months don't have the same all the same length, for example, and years don't have all the same length. So an NumPy has a special data type that is datetime64. Python also has a special class that is datetime. They are not the same. They don't have the same methods or abilities, so don't mix them up. If you're working with arrays and you're looking at dates, don't go and look at date time in Python because the information there won't be correct for you. Okay, so in fact, the datetime64 data type for NumPy is relatively simple. It doesn't have a lot of built-in capabilities. And what you need to use when working with time and doing some very fancy stuff on time series, it's something called pandas. We're not going to see it in details today because that's not the point of the day. But I just want to mention it to you because if you need it, then you know the name of it. And so pandas was also built on NumPy, except it expands the capabilities around dealing with date and time. So for NumPy, if you have a date, you can write it in different ways. So you can transform a string into a date. You give the string in this format. You don't need to specify everything, but it's just to give you the whole format. You can even put seconds, and it goes up to what was it, nanoseconds. So you can put a lot of zeros behind if you want. But it's typically the year dash, the month dash, the day, a T for time, the hour, and colon, the minutes, colon, seconds, dots, everything else. And then you specify a unit. So here I only specify up to the minute, but I want NumPy to consider it a millisecond in milliseconds. And here you see I give it up to the day, but that's a unit of months actually. So what it gives me, you see here it added all the zeros needed to create a milliseconds time. And here it got rid of the day because I told him I just wanted a precision of month, so the day, who cares? So you have to, that's what the unit is for. So obviously you can do some simple calculations. For example, if you want the number of days in February 2036, you can do 2036 March in days minus 2036 February in days. It will both start from the first. So this gives you that 2036 is a leap year and there's 29 days in it. So it can be a pretty handy way to know whether a year is a leap year or not. Obviously, you have to be careful of the unit, as I was saying, because if you do the same calculation with a unit of month, it tells you there's 1 month, so it doesn't tell you much if you want to know whether it's a leap year or not. So, yeah. Obviously, it's possible to convert units. So if you have already a date in months and you want to calculate whether it's a leap year or not, you can convert your dates from months to day. So here, for example, if I take 1988, May of 1988 in months unit, and March of 1990, and I want to know how many days there is between these two dates. If I do it in months, it will give me the number of months. If I use this, so it's my time, and I do a as type that to do the conversion, and so I want a type that is now a date time but in unit of day. And the same here, a unit of day, and then it will do the difference in terms of number of days. So in the first case, I know that between the 2 days, there are 22 months, and that corresponds to 669 days in this case. So this can be handy for doing this type of calculations. One more thing, you see when I do a print, I have a nice print, which is just a string that's very readable. Obviously, the result of the calculation is not that string. And the delta and delta D object here are actually numpy times delta 64 objects. And the print function gives a pretty output because of the way the object has been developed. It has been developed too. And so if I ask Python what it is without the print, it will tell me it's a numpy times delta 64, and it has a value of 669 with a unit of day. So using this, it can give me this nice printout with the print function. And that also means that if you want to print it in a message, you don't need to do fancy converting to string or anything. You just put it into print and it will appear nice in your message. Okay. So obviously that's relatively short in terms of dealing with time, but that was just to give you a bit of an overview that things are developed for you and you don't necessarily need to go and do it yourself. But is there any questions about this?
So Claire, in NetCDF, you're often given the number of days from a certain date.
Yeah, so we're going to see NetCDF after.
Okay, fine.
Although, yeah, although the example doesn't necessarily have time, but I'll explain after. I will show you. Okay, so this is all I wanted to say about NumPy to give. As you may have heard when Alex asked a question before, I don't necessarily use NumPy a lot these days anymore. And this is because something better came out, and it's called X-array. Okay. So what's the purpose of X-array? It introduces labeled arrays. That means that not only you get the data, but you also get the name of the field, the name of the dimensions, coordinates for the dimensions, attributes for the units for your field if you want to. Or so it's a bit like a NetCDF format for arrays. So it was very well with the NetCDF format. As long as you read good files that are very well described, you will get good data in that will have a lot of description in your code. And you won't have to remember was my time dimension on the left or on the right or wherever. Okay, one word of caution. X-array is relatively new. That means it changes quite a lot, which can be frustrating because sometimes you do something and then you come back to it and it doesn't work anymore because they change the API or whatever. And yeah, it is also a bit of a different way of thinking of things, which might throw you off at the beginning. I have a nice quote from someone on the help desk we got. He said, "I've been programming for 20 plus years and I hate parts of my existence in the X-array darkness." So it doesn't seem very promising like this, but it's actually very powerful, and it really works a lot, very well. And what is great is that it integrates very well with another package that allows for parallelization, and so it's very scalable to very big data sets. We're not going to see it here because we're just looking at basic Python, but I think it's important for you to know I would start with using that because later on it might really be useful for you. Okay. And X-array was built up on NumPy, so that's why we saw NumPy before, because you can use NumPy functions with X-array arrays. Okay, so let's import the package. Okay, so as I said, it was developed to work very well with netcdf files. So to open a netcdf file, you have an open dataset function. And I remind you that I'll show you, it's work with OpenDAP, so you don't need to only read local data. You can read data that has been published on the OpenDAP server. Here is data published during the previous center. So I can just run it, and I'll show you what has been loaded. So I get all this from that. So you see, it starts by telling me all the dimensions that are in my files, which is good. It gives me all the coordinates that are associated with these dimensions. And you see they're all like, that's called lat, and it's associated with the dimension lat, and it's a float, and that's the values, or some of the values in that array. And so that's only one dimension because that's a coordinate. And then after it's what is called data variables, so the data in the file. It gives me the name of all the variables, the dimensions of all these variables, and the type of the variables, and if there is space, it can give me a bit of data, but in this case, it didn't. So you see, really I get, and in addition, gives me all the global attributes of my file. So I just write one thing, and I get all the information from my netcdf file right away. Okay? Okay, so how do you get to the values? Each of the variables are stored in my dataset that I've just read from the netcdf file in a dictionary, so I can refer to them by name. So I was reading in DS, and I can say I want the variable RLS from this dataset, and I just write it like this. You know, it's just the name of it. And I can store it in different variables. And then when I get it, it tells me I have an X-array data array, that's the array type for X-array. It knows the name, it's RLS, it knows the dimensions, it can give me a few values, and it still kept all the coordinate object associated with it. And here I get all the attributes associated with a variable. So I know the long name, I know the unit, things like that. So to come back to your question, Alex, about the time, I don't know I haven't checked what the unit of the time in this file is, but if you see here, it tells me it's this date. I'm pretty sure, so X-array, when I read the dataset, will convert the time units to be something like that. So if it's a number of days since a certain date, it will take this date and add the number of days to give you a correct date and not just number of days. Does that reply to your question?
Yeah, it does. I guess then sort of some of the CMIT models, for example, had very strange calendars, like 360 days. It would also manage to do that?
So some of the calendars are a bit too tricky to do it automatically, but some of them work. So I would try.
Yeah.
And if it doesn't work, you have options in the open dataset to turn off the decoding of the time, and then you just read the data from the time, and then you can manually create your time coordinate again to be what you want.
Okay, yeah.
Okay, so what's the interest? So we think it's relatively good with netcdr files. What does it give me to have all these names and all this information? What it gives me is that then I can select data using the dimension names or the coordinate names or values instead of using indexes. So I don't have to remember the order of things. I just say, I want this one, and X-ray finds it for me. So you see in this case, if I want the mean along the latitude dimension, I can just say dim equal lat. So as long as I remember the names of my dimensions, it will work. And what is good is that if I change the ordering of the dimension, it still works. So, and just for info, X-array will try as much as possible to give you an X-array array as an output. So for the global mean, you don't have just a number, it's still an array, even if it's just one number, but it keeps it as an array. And here you see the latitudinal mean. It still knows your dimensions. It got rid of the latitude. And it still knows the coordinates associated with these dimensions. X-array was intelligent enough to know which one to keep and which one to get rid of. So, yeah. The other thing that is nice is when you want to have a value, when you want to know what are my values at the latitude minus 85. Normally you have to know which index is latitude minus 85. Here you just say, oh, I want to select the latitude minus 85, and it goes and works out for you what index it is in your array and get it out for you. So that's pretty nice, we find, because often you know the values you want and you don't necessarily know in terms of indexes. But it can be kind of a change of what you're used to. I would recommend getting used to the cell method, because that's really more powerful than just using indexes. And getting used to it early makes sense. Yeah, and in a way that is more powerful is that if you don't know exactly your values and you want, I want the data that is close to minus 87, but I don't know which latitude that is exactly in my data set, you can use like a kind of interpolation, and it will give you the data, and in this case, nearest, it will also tell you that it used the data that was at latitude minus 87.5. So you can just do that if you want, which is kind of nice too.
I have a question. Can you do it over 2 dimensions at the same time?
Yeah, you can.
Okay. Oh, that's great.
So you see, in this case, it takes minus 87.5 and 101.25. I'm not going too much into details of X-array because it's a whole training by itself. All I want to show you is why you should use it and why you should go like the minimum you need to know, and then where to get more information and so on. And there is a training. We'll have a training on X-array coming up. But I just wanted to tell you, just use it. you might be frustrated at times, but it's worth it. Okay. The other nice aspect of it is that it allows you to do very quick plotting of your data. It's not a publication-ready plot, but if you want to visualize what you're doing. So one word of advice, if you're working in Jupyter notebooks, for having your plot appearing in your notebook, you need this line first. This line has to appear before any of your plots, but it's just once in the notebook after it works. So you can put it at the start of your notebook if you want and forget about it. But so you need this, and then now RLS is a 2D array, so I can just plot it. And because it's 2D, by default, Xarray will give me a contour plot. And what is nice is I haven't done anything, but because it has all the coordinates and dimensions and names, it gives me the names and units, the name of the variable here with the unit. It tells me what time it was. I mean, you get a lot for very little work. So obviously, I don't have the continent outlines or stuff like that because Xarray doesn't know I'm on the world. It doesn't know that it's actually the longitude and latitude. It's just names for Xarray. But it's still very nice for a first look at data. And one more thing, it's using a package that's called matplotlib for plotting. And we're going to have a training on this. I just want to mention we haven't loaded matplotlib, but because Xarray uses it, when you load Xarray, it will load matplotlib for you as well. So don't need to stress out about that. Okay, so obviously you can, here it's a function where you have lots of options to customize your plot, but we're not going to see them now in details. But if you're curious, you can go have a look. Yeah. Okay, so now how do you write an SCDF file and save data to file? So it's actually very simple because there's a toNetCDF function and you just give it a data set or an array or whatever you have, and you say toNetCDF and you give it the file name and it will write the file name. What I've added here is that you should really take the habit of always writing compressed data. So I gave you a way to compress all your variables in a NetCDF file before writing it. So the compression happens at the level of the variable, so that's why you have to do it for each of your variables. That's where I'm thinking Xarray is something I did there because it'd be great to have a default option that says that you just say compression on and it just gives you a default compression for all your variables without having to do it yourself, but it's not there yet, so you have to do it this way. To get it to run through the code, so you first define an empty dictionary. Then you loop through your variables. So DS is a dataset with a lot of variables. Data vars is an attribute of DS that stores all the variable names as strings. And so I say in my dictionary, I want a key for each of my variables, and each of these keys associated with another dictionary, which is zlib, which is the compression algorithm, is true, so it will turn on compression for that variable. And then when you write it to file, you just say encoding equal your dictionary of you've just created. Yeah. You can do more complicated stuff about compression. Some people will say you should, but I think at the start, you can just do that. And as long as the problem with doing only that is that in some very specific case, you could end up having to spend a lot of time to read your data again because of the compression that happen. But in most cases, it will be fine. It will take a bit more time to read your data, but not a lot more time. So it should be fine for most of the cases. Okay, and that was a very short, no, not a short. Just in time training. So as I was saying, that's a very quick presentation of X-ray and how to use it. What I was trying to do is to show you, get you an idea of what the package was for, having the labeled data and using names and values instead of indexes. And we will run a more complete X-ray training soon. If you don't want to wait, X-ray has a lot of information online. So that's the X-ray documentation. They have a quick overview, kind of tutorial. So it's really full of examples, so you can just run them all and see what it does. They have the user guide is much more complete, but it's also full of examples, so you can also just work through it or just look at the bits you want. So that's if you want to use it, and obviously they also have some examples. I haven't really looked too much into that, but you can go through that and see if there's anything you want that would be useful for you. And the last thing is that we have a blog, and we have published quite a few blogs using X-ray and Python Engineer. So our blog is here. The blog posts haven't been tagged much so far, but there aren't that many either. So feel free to go through and see if there's anything there you can use or more information or things like that. So for example, there's a whole blog on doing line plots with X-ray, or there was another one I forgot. If you want to measure arrays with missing data, or to use a variable to mask another variables and stuff like that. So there are other things. There are a lot more than that, but yeah. That's it for today. Do you have any questions?
How do you extract data from a specific long single point? A vertical profile, for example.
So how do you, you have an array that is like a 3D array, and you want to get only, so you will use like this. You select your latitude and longitude, and it will, if you have a level dimension, then it will give you all the levels for that position.
Okay.
In this case, it's only 1 point because it was a 2D array, but if I had more dimensions, it would keep all the dimensions, all the other dimensions I haven't selected. And you can, if you're interested in vertical profiles, the line plots with X-ray blog, there was quite a few vertical profiles there at some point.
Oh, great.
Here. You see there are examples of vertical profiles. You can have a look.
Excellent. Thank you.
Anything
Hi,
else?
Claire. Yes, here. So do I have to always open the whole netcdf file and then find if I just want a specific region of lat and long later after I open it, or can I just extract that information?
Okay. So it's something I didn't say. So when you read your file, it doesn't actually load the data. It will only load the metadata. It will know what the data is, but it doesn't load the data. So it doesn't matter that you load the whole netcdf file. And then when you select, it will even, not even when you select, it will load all the data. It's only when you plot, for example, that it will suddenly need to get the data in, or when you do a mean, something like that.
So the mean operation will take longer because that's when it's actually loading the data.
Yeah.
Okay, thank you.
If your file is, I think if your file is small enough, it might load. No, I don't think even it will load it to. There is ways to load the data before doing operations if you want to, if you know that it's small enough for your memory, but usually it's not needed.
Thank you.
Anything else? If there isn't,
So does that mean, sorry, does that mean that you could concatenate lots of different netcdf files without
so,
it actually being memory?
yeah, so I didn't talk about it. There is another function that's called open_mf dataset for multiple file dataset. And that means in the string here, you can give it a pattern, with star or whatever, like a Unix pattern, and it will concatenate the data it will look like one data set in your program, but it will know that it's in different file and then works from different file, yes. Does that answer your question?
Yes, yes. Yeah, that seems very useful.
Yes. So I'm pretty sure. I think in MATLAB you have to read each file one by one. Here you can just. So for example, files that are published are often separated by variables or per time per year, and so you can just say I want to read all the files in this directory, and it will all concatenate all the years together, and you have the whole time series there.
Can we maybe do this as a tutorial in the future?
The opening multiple files at the same time?
Yeah.
Yeah, it will definitely. It will definitely be in the XRA training, that's for sure. Yeah.
Okay.
Yeah, I would have shown it to you, but I don't have a.
Yeah.
I don't have a. I don't know. Anyway.
Maybe by next week I know how to do it.
It's not that complicated necessarily, as long as you know how to write a pattern in Unix,
Yeah.
to describe your files, and you put the same pattern there and it should work. Although sometimes you have to be a bit more tricky to make sure that it's sorted in the right order, but yeah, we could definitely. We could also plan to have a new blog by next week that goes through that, if it's not already there. Could be added. So that was my other question. If there's no more questions, I would like to know, is there anything you wanted to know that we haven't covered yet, so that we can target these in following trainings?
A bit more on netcdf plotting would be really helpful.
Okay. And what type of plotting? I mean, you were talking about vertical profiles, but are people more interested in maps, in like line plots, in time series, in all sorts of plots? I mean, what's
Yeah, all of it.
all of it?
Yeah, so publication ready plots, so maybe contour maps, multiple contour maps superimposed on each other, sort of more complex things like that, maybe.
Sure.
And I think also going back to this X-array thing, sort of efficient ways of calculating climatologies and anomalies would be useful.
Yeah, that's definitely coming. But as you can imagine, it's a lot of information more. I mean,
Yeah.
to add. So we thought it was better to keep the basic Python to 3 weeks, give you a bit of time to digest it all, and then come back to Python a bit later to add to it, because otherwise there's another flow of information. And I would advise you to even start with that. Don't worry about being not so efficient at the start, because what you need to do first is getting used to writing in Python and things like that. And then after you can look at what's the best way of doing things, etc. But obviously in the example in X-ray, there is like, I think I saw something about climatology, filling with climatology, or monthly anomalies, things like that. So definitely looking through these examples would be interesting. And obviously, because it's basic Python, we haven't discussed at all how to deal with very big data sets and stuff like that. So I don't expect you to start with that, because otherwise that's more complicated than basic. Anything else? Or? Okay, then I think we're good for today. Next week, if I'm not mistaken, we're going to have a training on licensing for when you publish datasets. Have a different type of how to choose a license.